Hey guys, this is difference of squares factoring. There's a couple things we'll go over here. All of these are going to be talking about difference of squares. It's, once again, a type of factoring. Most of the ways we're going to do this is with quadratics. It doesn't have to be a quadratic if you don't know what the heck I'm talking about. Quadratics are the things with x squareds in it. Technically, difference of squares you can use for anything that is a square. Which would include things like x to the fourth and x to the sixth. Anything with an even exponent you can take the square root of, which is why they're calling this the difference of squares. So just an example that you're going to see on something like a test or a quiz eventually is like x squared minus 9. This is called a difference of squares. First of all, it's called a difference because there's a minus sign. And then it's called a difference of squares because both of these things are square rootable. That is, you can take the square root and get an integer, or in this case, just a variable. The way you do it is pretty easy once you've started memorizing. I'll show you the easy memorized way, and then I'll show you a different way to think about it. So in a difference of squares, you're just given a problem. We'll say this is number 1. You set up your set of parentheses, because in almost all types of factoring it's going to look like that. And what you do is you square root the first part. In this case, the square root of x squared is an x. And then you square root the second part. The square root of 9 is 3. And the trick is you take the square root of each part, put them down. One is a plus and one is a minus. And that's the entire question right there. Done. No more. For another example, if I was to give something like, let's go 9x squared minus 25. This is also a difference of squares because you can square root this and you can square root that. And once again, you can set up your answer parentheses like that. And you take the square root of this. So the square root of 9x squared would be 3x. And then the square root of 25 is 5. So plus and then minus. Now, like I said, the trick is do it twice, one's a plus, one's a minus. Do it twice, one's a plus, one's a minus. One's a plus, one's a minus. One is a plus and the other is a minus. Take the square root, put them down. However, a lot of people kind of mess that up. They're like, oh, this is a minus, so they're both minus or something like that. No, this is the other way to think about it. If you have, let's go with number 3, an x squared minus 16 this time. You set up your parentheses. The square root of this is x. The square root of that is 4, so they would both be x and a 4. That's fine. But here, remember that factoring is supposed to be the opposite of FOILing. That is, if you did x times x, you would get x squared. If you do 4 times 4, you get 16. And what would happen if you FOIL these middle parts and these outer parts, or I suppose we call them inner and outer, the inners would give you 4x, and the outers would also give you 4x when you multiply them, right? 4 times x and x times 4. But keep in mind that that is supposed to multiply. These two are supposed to multiply to negative 16. And if you were to make this a negative and a negative, then a negative 4 times a negative 4 would give you a positive 16. You don't want that. So I usually just say, well, what's the only way to multiply to a negative? And, well, the only way to multiply two numbers and get a negative is if one is positive and the other is negative. So you need to have this positive 4 times negative 4 is negative 16. And at the same time, if you were like FOILing out, you would get a 4 times x and then an x times negative 4. And those just cancel out, which is why there's no middle term here. Which leads me to the other way of thinking about it, which, beginning out's not a bad way to think about it. It's just the more and more you do these things, the less imperative it is that you think. And you just kind of like, oh yeah, it's that thingy, let's do the thingy, and then we're done. And we have motion-activated lights in this classroom. Sorry about that. Anyways, so let's just do another one. Let's go with x squared minus 100. like so. So the other way you can think about it, in class we did this thing called an X method. Basically, the last number, called the constant, which has no X attached to it, goes in the bottom here, and then the middle number goes in the top here. But as you can see, like negative 100 is definitely the last number, but there is no middle number. There's literally nothing in the middle. So if there's nothing in the middle, what number is nothing? Well, nothing is 0. This is just an organization way. It's just saying what multiplies to negative 100 and adds up to 0, because there's no middle term. And if you go through all the possibilities of what multiplies to 100, you would eventually find that the way that they would add up to 0 is if you had 10 and negative 10, like so. So 10 times negative 10 is negative 100, and 10 minus 10 is 0. So you would get, this is a positive 10, so x plus 10. And this is a minus 10, so x minus 10. And that is now factored. Done. I do want to cover one, or actually two other things, I suppose. Let's say I had something like x squared plus 36. It is important to note that this is not factorable. The whole thing with difference of squares is that every single one of these has a minus sign. It's supposed to have a minus sign. It is a difference of squares. As soon as you have a plus sign in these, you would just write not factorable, because it is not factorable. And you would be done with it. Then you come across crazy problems that math teachers love to do because they like you getting things wrong. No, I'm just kidding. This is just kind of like a test for concept kind of question. Sometimes things will be like, hey, factor by any means possible. And then they give you something like, okay, 2x, I'm sorry, I screwed that up. 4x squared plus 1, 4, there we go. In which case, like, you could square root this 4x, you could square root this 4, but you're not supposed to. It's a plus sign, so it's not a square, not a difference of squares. This problem is actually a greatest common factor problem. 4 goes into this, and 4 goes into that. So if you factor out a 4, you would divide each of these by 4, and you would get x squared, bring down the plus, and then 4 divided by 4 is 1. And this, once again, is not a difference of squares. You can't actually factor this more. Yes, you could square root them, but it's not a difference. So this would be the answer with a GCF. And the factor by any means you can. The factoring type was GCF. And then you get really, really awesome problems. I'm not biased at all. Things like 2x squared minus 50, where it's like, well, you can't square root that, so it's not factorable. Except it is, because like I said in number 6, like GCF works. If you were to see that this is a 2 and this is a 50, they're both even numbers, you can divide them by 2. If you divide them by 2, you get x squared minus 25. But once again, this is a difference of squares. You could square root them, you would get x and 5. And then bring down the 2. And the way to get it to be negative is if one is positive and the other is negative. So it's time for things to be factorable more than once. It can be GCF and difference of squares. And then if your math teacher really hates you, they'll give you this problem, x to the 4th minus 1. It is not a quadratic, but you can take the square root of it. If you take the square root of each of these, then it would be an x squared. By the way, this 2 comes from dividing the 4 by 2, not by square rooting it. The way exponents work is that with a square root, you divide them by 2. And then the square root of 1 is 1. Boom, 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 boom. So the square root of 1 is 1. 1's a plus, 1's a minus. Except that is also a difference of squares. That is not because of the plus sign. But this one, you can take the square root of both parts, and you'd get an x and a 1. and then it would be a plus or a minus. And this thing is not factorable. And you would get this. So I might have done that a little bit fast. Feel free to rewind and rewatch it or pause throughout the question, but it's a difference of squares because you can square root the 1 and you can square root the x. But then this one was difference of squares again. And yeah, then this is not a difference of squares, and this isn't, and this isn't. And that would be the final answer. So yeah, that's difference of squares. Hopefully it helped a little bit. Once again, the biggest takeaway I want you guys to get is for problems like 9x squared minus 100, where you can square root both parts to get 3x and 10. And then you put down another 3x and 10. One's a plus, one's a minus. Those will be the most common, so that's what I care about the most. But all of it could happen. All of it will happen. It's just this happens the most. Anyways, have a good one. I'll see you guys on the other side.